Hello, everyone, and welcome back. My name is Mr. Kovalt, and in this video, I'm going to go over equation stoichiometry. And again, I'm going to go over a third problem where I show you to do a mass-to-mass conversions. So let me just preface this by explaining what you would do in this sort of problem. So here's the roadmap that you want to be very familiar with. So the main highway, in a lot of stoichiometry, I would say the vast majority of stoichiometry problems, especially the mass-to-mass conversion ones, you're going to be going from grams to grams, right? But in a lot of problems, you're not going to be giving grams right off the bat. You're giving some other form of mass. Maybe it's pounds, maybe it's ounces, maybe it's kilograms, megagrams, whatever it is. You're going to have to convert from that unit to grams, and then you can use molar mass to convert to moles. So why do you want to convert to moles? The idea is that you want to convert to moles because you have to use the mole ratio in your balanced equation to convert from moles of one thing to moles of the other thing. So to get that conversion from one substance to another, you got to go through the mole ratio. So whenever you're doing this sort of stoichiometry problem, you've got to get 2 moles. And even if it's not this sort of problem, if it's not a mass to mass conversion, maybe it's liters to mass or liters to liters or whatever the case may be, your goal is to get to moles. Once you've got to moles, you can now use your mole ratio to convert from one substance to the other substance. And that is the key to stoichiometry, using your balanced equation. Okay, so in this video, we're going to be doing mass to mass. So here, we're starting with some unit of mass. We got to get to grams. Remember, our goal is to get to moles. Once we get to grams, we can use the molar mass to convert to moles. And then from there, we can use the mole ratio in our balanced equation between the two substances that we're interested in. Once we got the moles of our other substance, the desired substance, then we just use the conversion factors that we need to use to convert to whatever the unit is, in this case, mass. So again, use the molar mass of your substance 2 to convert back to grams. And then if you need to convert to a different mass unit, then use whatever conversion factors you need to convert to that unit. Okay, so let's look at the problem that we're going to be doing in this video. And so here here's the equation. I've done this equation before in my previous video. Now we have a different question. So here we're asked, what is the maximum mass of this substance, C2H4, that can be formed from 23.75 grams of the C2H4Cl2? Okay, so they're giving us kilograms and we want to get to a mass. They're not telling us what unit, so we might as well convert to kilograms. Since they're giving us kilograms of a substance, we might as well convert to kilograms to get it to be about the same. So we're going to start with the amount of substance they give us. So they give us 23.75 kilograms of C2H4Cl2. And we're going to put that over 1, and we're going to start by the conversion factors. So remember, the goal is to get to moles. We've got kilograms. If I could get to grams, then I can use the molar mass to convert to moles. So in this case, I'm going to need, oops, I got myself turned around here. So I'm going to need to convert kilograms to grams first, so that way I can use the molar mass to convert to moles. Again, the goal is moles, so kilograms. I need to know the relationship between grams and kilograms. Kilo is 1,000, so I know 1 kilogram is equal to 1,000 grams. So I'm going to write that down. Kilograms is on top, so I'm going to put 1 kilogram of the C2H4Cl2. Okay, so we got that. So then we're going to put the 1,000, 10 to the 3, or you could just write 1,000 there. 10 to the 3 is 1,000. So that's going to be C2H4Cl2. So kilograms cancel out. Now I've got, oops, I forgot my grams. Don't forget the unit. Remember the other thing, oops, I'm dropping things all over the place. Okay, So remember, I am writing three things for every conversion factor. I'm writing the number, the unit, and the substance. Always write the number, unit, substance together. That will keep you from making simple mistakes. So I got grams on top. Now I can convert grams to moles using the molar mass of this substance. So I got to calculate that, and you got to calculate it too. So I already calculated it. I calculated it as 98,945. So 98.945 grams. And that's going to be of this substance here. So C2H4Cl2. And since I put grams on the bottom, since I have grams here, and so that's equal to 1 mole of this substance, 1 mole of C2H4Cl2. So the grams of this substance cancel out. Now I have moles on top. So now I can use the mole ratio from my balance equation to go from C2H4Cl2 to the C2Cl4 that they're asking me about. That's my desired substance. So I look at my balance equation, and here's my C2H4Cl2. So 8 to, where is it? H2 8 to 4. So I want C2Cl4, that's there. So I have an 8 to 4 ratio. Now you can simplify it. I don't like to simplify the numbers. I'll let my calculator do that. So I'm going to continue down here with the conversion factors. So since I have a mole of C2H4Cl2 on top, I'm going to put that on the bottom. So that's going to be 8. So 8 moles of the C2H4Cl2 on the bottom, and the 4 moles of C2Cl4. So 4 moles of C2Cl4. So the moles of this substance cancels out. Now I have moles of the C2Cl4. Now look where I am. I've gone from the unit in kilograms to grams, then from grams to moles using molar mass. Now I've converted moles of substance 1 to moles of substance 2 using the mole ratio. Now I can go from moles to whatever unit they're asking me. In this case, they didn't really give me a unit. They just said mass, maximum mass. So we're going to convert this back to kilograms. Since they give us kilograms, we're going to convert it back to kilograms. So now my goal is to get back to kilograms. So in order to get to kilograms, I got to convert to grams first. So I'm going to have to use the molar mass of my other substance. So notice that here, moles to grams. So I got to convert moles to grams first before I do anything else. So I got to get into a mass unit. So if I'm converting to a mass unit, I got to get my moles into mass unit. And the easiest way to do that is molar mass, because I can convert that to grams, which is a mass unit. So now I need the molar mass of this substance, which I already have. It's 165,822. So here, the 1 mole of the C2Cl4 goes on top, and the 165.822 grams, let me double check, 165,822, yep, grams of this substance goes on the bottom. So C2, that's going to be Cl4 on the top. So moles of this substance cancels out. Now I have grams of the substance on top. And now I have one more conversion. I got to go from grams to kilograms. I'm going to use the same conversion here, except I'm going to flip it because I got to go from grams to kilograms. So I'm going to go ahead and put that down. So I have grams on top. So I'm going to put 1,000 grams, or 10 to the 3 grams. Oops, let me make that clearer. So 10 to the 3 grams of this substance, C2Cl4. and then 1 kilogram of C2Cl4 on top. Now grams of this substance is going to cancel out. Now I have kilograms of C2Cl4. That's the unit we wanted. So now we are done. No more conversion factors. So now all I need to do is multiply everything on the top and then divide by everything on the bottom, and I'll get my answer. And I got the answer. What did I get? I get 19.9013. So that's going to be equal to, I'll put it down here. So 19 point, what did I say? 9013. So 9013 kilograms of the C2, oops, that should be Cl4, not H4. Cl4. Okay, so that is the answer I got on my calculator. There's a few other digits. I didn't write those. So now for those of you that are interested in sig figs, I need to figure out how many digits to keep. So the rule for multiplying and dividing is that your answer should have the same number of digits or sig figs that is the lowest number that you get from your measurements. So again, my answer should have the same number of sig figs as the measurement with the least number of sig figs. So I got to go back to the measurements. We're going to ignore anything that's exact. So metric to metric is exact. So this conversion factor will ignore, and this conversion factor will ignore. Mole ratios are exact. They're just numbers of moles related to each other. So this 4 to 8, we're going to ignore that. So the only things that we need to pay attention to are the molar masses. So this molar mass has 6 sig figs, and this molar mass has 5 sig figs. And this measurement that we're given of our first substance has 4 sig figs. 4 is the least number, so 4 is the number of sig figs that our answer should have. And so we got 1, 2, 3, 4. So we're going to have to cut it off there, drop that. This is a 1, so we don't need to round the 0 up. So the final answer would be 19.90 kilograms of C2Cl4. And that, ladies and gentlemen, is how you do a mass-to-mass conversion using your balanced equation, and that is equation stoichiometry. Thanks for joining me. If you love this video, then please hit the like button. If you like the video, hit the like button. Also, make sure that you share this video with your friends. Subscribe to my channel. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section, please. Let me know what you think. Ask me questions. I would love to hear from you. Maybe if you have a problem you want me to go over, or a question you want me to answer, or maybe you have a topic you want me to cover in a future video, then please let me know. I would love to do that for you. Thanks for joining me, and have a great day.